All right, 2.7, proving theorems about angles. We've been talking about proofs over the last few. Now, I'm sorry if I put some notes on late last night. It just things were just going on, and I couldn't get them up till later. I did text, so hopefully you saw them. Got to see 2.6. If you didn't, they're online now, so you can see them. It's kind of a same scenario as this stuff. We're still looking at the statements and the reasons, and trying to get figure out what kind of reasons we can use to make sure that we know things are true statements. So let's take a look at 2.7. A contractor has submitted a proposal for construction of 2 new runways at a municipal airport. The contract states that the new runways will have the same orientation as the old runways. So you can see that here's the proposal, your new runways. Okay, you've got your this is your old runways down here, 3 and 4. So you can see it's going the same kind of direction. So you can kind of see that these are parallel here, and these are going to be parallel here. Before the Airport Construction Board can approve the contract, it must verify that the new runways in the proposal are properly aligned. The proposal contains a construction diagram which specifies that angle 2 must equal angle 3. Okay, so that has to happen. 2 and 3. Now notice the red arcs that I put here. That means that those are equal. When you want to show on a paper that angles are equal, you put arcs in there. One arc matches up with one arc, so 2 is going to be congruent to 3. To verify correct runway alignment, one board member offers the following logic. Well, if the measure of angle 2 equals the measure of angle 3, then the measure of angle 1 has to equal the measure of angle 4. Use a 2-column proof to determine if this logic is correct. Okay, so first off, angle 1 is the supplement of angle 2. Angle 3 is the supplement of angle 4. What reason could we give for that? Okay, basically those are going to be given. Is that they're supplementary? Because we are, I forgot to tell you the given part, my bad. Given is that measure of angle 1 equals measure of angle 2, and that 1 is the supplement of 2, and 4 is the supplement of 3, and we want to prove that 1 and 4 are congruent. So that's our job, so I'll let you take a second to fill those two in. I'm going to move it up a little so you can see it at the top. Okay, so 2 and 3 are congruent, or equal. So that's one thing we know and given. 1 is the supplement of 2, and 4 is the supplement of 3. Those are also given. And we want to prove that 1 and 4 are congruent. Now remember, things have to go logically, so your second step should build off your first step. If the first step says that they're supplementary, the second step says that they add up to 180. Because what does supplementary angle mean? Add up to 180. So we can't put this one first. We have to put supplementary first, and then we can say they add up to 180, because that's what supplementary is. So that would just be definition of supplementary angle. What supplementary means is that they add up to 180. So again, we've got to work our way logically down a proof. You can't start with the one equaling 180 when you haven't shown that they're supplementary yet. The only way you can say that they add up to 180 here is because you have to show first that they're supplementary angle. That's just definition of supplementary. Now take a look at how we build from 2 to 3 now. If these two together equal 180, and these two together also equal 180, then what can you say about the two left sides? That they have to equal, because they're both equaling 180, right? I could basically take the 180 out and put the 1 and 2 in its place, right? Because they're equal. So that's kind of what we did. We did substitution there. You took out 180 and you plug in 1 plus 2 in its place, or you took out 180 and put 3 plus 4 in its place. Because they're equal. When you have equal pieces, you can substitute them anytime. Again, just working our way down the chart. Because we said that they both add up to 180, now we can say that both sides are equal. Now 2 and 3 are equal. Where did I get that from? That kind of came out of nowhere. That's where. That's back at the given. Okay, because now we're going to use this now. So we want to put that as given. Now you can put given anywhere you want in your proof. Usually we're going to leave them at the top just so they're already there. But we can prove that 2 and 3 are equal to each other. So could I take out 2 and put in a 3 if I wanted to? Could I take out 3 and put in a 2 if I wanted to? Okay, what did I do? Look at what they did here. They had a 3, and now what do they have? A 2. What did they do here? Substitution again. They took out the 3 and they put in a 2 because it was equal. Now, how do you think that all of a sudden 1 and 4 are now congruent to each other? Okay, well, hold on a second. Look what's in both sides. Could I, in my Algebra 1 days, subtract the measure of angle 2 on both sides?
Yeah.
Would that be okay? Yeah, because that's just algebra. You can subtract the same amount on both sides. These will now both cancel out, and what do you have left? Angle 1 equals angle 4. So what would I have to put here? What did I do? Subtraction property of equality, or subtraction property. Subtraction property said you can subtract on both sides, and it will stay equal. If two angles have the same measure, they have to be congruent to each other. That's just definition of congruence. If they're the same measure, they have to be congruent. Definition of congruence. Okay, so hopefully you're starting to see how things have to work down logically. You can't start with the second step if you haven't given me the first step yet. You can't go to the third step unless you've told me the second step yet. So you work your way down, you try to get it to where you can prove the statement that you're looking for. All right. Again, these will be online later. If you miss any part of it, you can go back and check it out. Okay, complementary angle theorem. This is what it says. If angles 1 and 2 are complementary, and angles 2 and 3 are complementary, then what can we conclude about angles 1 and 3? And we're going to plug in some numbers and find out. Just as a side note, what does complementary mean again? They make a corner, right? They add it to 90. Complementary is corner, so they add it to 90 degrees. So that means I need 1 and 2 to add up to 90. And I need 2 and 3 to also add up to 90. Okay, so let's see what kind of number we can maybe put in. What if I put in 25 degrees for 1? Just throwing a number in there. I'm not saying that that angle is exactly 25. It might be if I put my protractor on there and measured it. But let's just say that's a 25-degree angle. Yeah, we're saying angle 1 is 25 degrees. Put that in the box. Put 25 degrees in the box. Do we know any of the other two angles now? Well, we know that 1 and 2 are what? Complementary, which means they have to do what? Equal 90. So if this one is 25, what does 2 have to be? It has to be 65. Has to be, no doubt, because we know that 25 and 65 will give me my 90 degrees, right? They have to be complementary. What do we know about angles 2 and 3 on in the problem? They're also complementary. Okay, so angle 2 and angle 3 have to also add up to 90. Have to. So if 2 is 65, then what does 3 have to be? Has to be 25. Because these two have to add up to 90. So can you see if they have an angle in common and both pairs add up to 90, what has to happen to 1 and 3? They have to be congruent. They have to be the same. So what can we conclude about angles 1 and 3 is that they are congruent. They have to be congruent to each other. It's called the complementary angle theorem. If two angles are complementary to the same angle, they're equal to each other. If 1 and 3 are both complementary to 2, they have to be equal to each other. Complementary angle theorem. Okay, supplement of an angle is 3 times the complement of the angle. What is the measure of the angle? That's just a challenge, thinking problem. the supplement of an angle is 3 times the complement of the angle. How would we solve that? Think about supplement. What do they mean? Okay, so how do I find the supplement of 100 degrees? Subtract it from 180, right? So if I don't know what it is, I'm going to take 180 and subtract x. That's the supplement of an angle right there. Okay, so this right here represents supplement of an angle. The supplement of an angle is, what's is? Equals, that's our is, 3 times the complement. Okay, we got the 3, right? We just need to fill in that. How do you get the complement of something? Okay, so this is the supplement of something, so what's the complement going to be? 90 minus x. 90 is the big number. They have to add up to 90. The 90's got to go first. Okay, could we solve that? So this would be right here, would be 3 times the complement. Could we now solve this problem? Yeah, we should be able to. 180 minus x equals, and we're distribute here, so 270 minus 3x. Let's add 3x to both sides. That's going to give me 2x. And let's subtract 180 on both sides. That's going to give me 90. 2x equals 90. X is going to be 45. So what is the measure of the angle? 45 degrees. So 45 degrees would be our x. 3 slices of pizza. I don't know how big your picture is on the paper. Can you see the letters? Yeah. Okay, there are 3 slices of pizza left. It says you may have 2 adjacent slices. You can pick 2 of them, and they have to be adjacent. Okay, piece S and piece U are exactly the same size. That is, the measure of angle 1, if you can see the 1 here, equals the measure of angle 3. Which is a better choice? Should you take pieces S and T, or pieces T and U? You're starving and you can pick 2 of them, and they're adjacent, they have to be adjacent. Which 2 pieces would you want to pick? S and T? T and U? Okay, so remember, this one and this one are equal. 1 and 3 are equal.
I'm doing it.
Yeah, I heard over here, I heard either one. Either one is your right answer. Okay, which is a better choice? Either one. The one with more pepperoni. That makes sense. Think about it though. T is a common piece. You're going to get T no matter what. It's got to be adjacent. And 1 and 3 are exactly the same size. So it won't matter which out of those 2 that you pick. So if you pick S and T, you're going to get the same size as you would if you picked U and P. So why did I put either one? Either one would be the one you want. So I heard somebody say more pepperoni. Alright, so either one is the right answer there for that one. Alright, let's take a look at the last one here. Okay, this one is actually for you to do tonight if you want some extra credit. Okay, it says 2 plus 2 equals 0. What? I thought that 2 plus 2 equals 4. The following proof shows that indeed 2 plus 2 equals 0, unless you can find a mistake. Here's your given, x equals 2 and y equals 2, then 2 plus 2 has to be 0. Okay, let me show you the steps. X equals 2, y equals 2, right? X equals y. Good so far, x equals y? Because they're both 2's. X squared equals y squared. You okay with that? Square both sides. X squared minus y squared equals 0. Subtract y squared on both sides. We good? Okay, so let's start filling these. These are both given. This one was substitution. This one was squaring both sides. And that was subtracting on both sides. So everything's good. We're just doing our algebra skills. X plus y times x minus y equals 0. What did I do there? Back in your Algebra 1 days, you factored a difference of squares. Remember the x squared plus y, or x squared minus y squared, you get x plus y, x minus y. When you break it down, that's factoring a difference of squares. X plus y equals 0. I divided x minus y on both sides. Divide both sides by x minus y. If you want to get rid of this x minus y here, so you divide it on both sides. 2 plus 2 equals 0. We substitute it back in. There it is. 2 plus 2 equals 0. Completely explain with your algebra skills. If you find a mistake, if you don't think 2 plus 2 equals 0, you can put it on a piece of paper with your name on it. Put it on my desk. Get yourself to make the point.